All right, problem 3E, same idea as before. We need to try and recognize a pattern here and determine if it is geometric or not. But regardless, we would like to write the general term a sub n for this. So like I've done before, I'm going to list out the term number below each of these because that is often helpful for us. Again, notice that we have a fraction, so it's useful also to look at the numerator versus the denominator and find a pattern in each of them. So let's go ahead and look at our numerator. In the numerator, look that each time we are increasing by a power of negative x squared. 1 times negative x squared is negative x squared. Negative x squared times negative x squared is positive x to the fourth. Positive x to the fourth times negative x squared is negative x to the sixth. So that pattern will totally work. So a sub n is going to equal, and also notice each time that the exponent, if you remember, we're increasing by powers of negative x squared. So each time the exponent on that expression is 1 less than your term number. So negative x squared to the power of 1 is negative x squared. Negative x squared to the power of 2 is x to the fourth. Negative x squared to the power of 3 is negative x to the sixth. And again, notice that that exponent in each case is 1 less than your term number. So we're going to get negative x squared, and we know that each time the exponent on that entire expression, negative x squared, is 1 less than our term number, n. So now let's look at our denominator and find our pattern that's happening there. So same idea as we just did. This one's easier to see. We're increasing by a power of 3 each time in the denominator. And again, list them out. So we have 3 to the 0, 3 to the 1, 3 cubed, 3 to the fourth is 27, 3 to the fifth is 81, etc., etc., etc. Sorry, I'm a liar. I can't count. 3 cubed is 27, and 3 to the fourth is 81. So again, in each instance, the value of the exponent is 1 less than the term number. So we're going to get 3 to the n minus 1 back there. And we've seen this already. We can rewrite this as negative x squared over 3 all to the power of n minus 1. So our constant ratio r is that whole expression, negative x squared over 3. Kind of crazy. So just like before, we want to figure out when does this geometric series converge. Well, again, that only happens when r is between negative 1 and positive 1. So substitute our r value in, and we'll get negative 1 is less than negative x squared over 3. And simultaneously, we will get negative x squared over 3 is less than 1. And let's solve these equations for x. So let's multiply by negative 3 on both sides, and we'll get 3 is greater than x squared, because we had to flip our sign because we multiplied by a negative number. And we will get x squared is greater than negative 3 over there. So take the square root of both sides, and we get that x is less than the square root of 3. And we get that x is greater than the square root of negative 3. Oh, weird, that's crazy. We're getting into non-real solutions. And then also don't forget that we're dealing with positive and negative square roots here, so this is getting even messier, and we're just going to stop it right there.